Today we're talking about multiplying rational expressions and dividing rational expressions. Let's begin by talking about multiplication of rational expressions. These are the types of problems that we did in class yesterday and you had for homework last night. So remember, in every case of multiplying fractions, what you're trying to do is you're trying to factor the numerators and denominators. That's to get them into smaller factors. That way you can see if there's anything that can be canceled on the top and the bottom, because anything divided by itself is 1. And then you would multiply together anything that is left over. So for example, if I have 7/4 times 7/5 x, I would look to see if I could cancel anything first. But there's nothing to cancel because there's nothing the same in the numerator and the denominator. So I would then go ahead and I would multiply the top times the top and the bottom times the bottom. In the next problem, you can see that actually we can do some canceling first because both the 4 and the 6 can be divided by 2. 4 divided by 2, 6 divided by 2. You also may notice that now there is a 2 on the top and the bottom, and so I can go ahead and cancel again. 2 divided by 2 is 1, and 2 divided by 2 is 1. Now I have to be careful in multiplying together the top times the top, so all I'm left with on the top is a 1 times a 5. And all I'm left with on the bottom is 1x squared times 3. And so that would make 3x squared. So as we said, we are looking to factor the numerator and the denominator to see if any of the factors are the same in both the numerator and denominator so that we can cancel. In this next section, I can see that this is already factored because I have a parentheses times a parentheses. And here I have a GCF of 10 that was taken out. So this is already factored. So step 1 that we normally would take is already done. So I'm going to go ahead and go to step 2, which is to cancel anything that looks alike in the numerator and the denominator. So I have a b plus 4 in the numerator and a b plus 4 in the denominator. So I'm going to go ahead and cancel those two things out. I can also see I have a b minus 2 in the numerator and the denominator, and I can cancel those out as well. Be very careful now to make sure that you write what's left. So on the top I have a b minus 4, and on the bottom I have a 10. I have a problem here that you are going to try and see what you get. So again, keep in mind that you always need to factor the numerator and denominator first, cancel if possible, and multiply what is left. So on this next example, I'm going to go ahead and factor out on the numerator and the denominator. The first fraction here cannot be factored any more than it already is. But the second fraction has a 10p GCF in common in the numerator. So I'm going to go ahead and factor out 10p. When I divide 10p squared by 10p, I get p. 50p divided by 10p is 5. The bottom is just a 7 and cannot be canceled any more than that. Now I'm going to go ahead, now that I've factored, and look for anything that can be canceled. And I can see that I have a 10p on the top here and a 10p on the bottom there. So I'm going to go ahead and multiply those two, cancel those two things out. Now I need to write what's left behind. So I have a 9, a parentheses, a p plus 5, and that's over 7. You can either leave it that way, or if you wanted to, you could distribute the 9 back in the numerator, and that would be okay as well. Again, we're going to factor numerators and denominators first, cancel if possible, and multiply what's left. So in this next example, 4v squared is as simple as it's going to get. V squared minus 9v plus 18. I know I'm looking for two numbers that multiply to make 18. They have to add to make negative 9. Those two numbers are negative 6 and negative 3. Second fraction. Oh, I just noticed that they're exactly the same. So this also ends up to be v minus 6 times v minus 3. So what I could have done right away, had I noticed and been observant, I could have canceled them right away, but I didn't notice. That's okay, I factored, and here I can see the v minus 6s would cancel, and the v minus 3s would cancel anyway. Again, after canceling, you're going to write down what's left. So I have a 4v squared on the top, and I have a 3 on the bottom. Again, factor numerator and denominators. If I factor the numerator of this one, I end up with p minus 9 times p minus 4. If I factor the denominator here, I see that there's a GCF of 9. So I would go ahead and take that 9 out. P plus 10 is as simple as it's going to get, so I leave that alone. And factoring the denominator of this other fraction, I can see I have a 7p squared in common. So I'm going to go ahead and factor out 7p squared. It leaves me with p minus 4. Factoring numerators and denominators is done. I'm going to go ahead and cancel. So here I can see the p minus 4s are the same on the top and the bottom. I can see the p plus 10s are the same in the top and the bottom. And that's all that I have that is exactly alike. So I have canceled. I'm now going to multiply what's left. So I'm going to go ahead and write down that there's a p minus 9 left on the top. And on the bottom, I have a 9 times 7p squared. 9 times 7p squared is 63p squareds. I'm going to go ahead and have you try this one, and we'll see what you get. We're now going to talk about division. You may remember from your middle school days someone telling you at some point maybe keep, change, flip. That's dividing two fractions. You keep the first one, you change the division to a multiplication, and you flip the second one. For example, I would keep this one. I would change this to a multiplication, and I would flip the second fraction. Keep, change, flip. Now you can see that you're going to just follow your multiplication rules, because now it is a multiplication example. So remember, in multiplication, we're looking to see if we can cancel, but there is nothing the same on the top and the bottom. So I'm going to go ahead and multiply top times top, and bottom times bottom. Let's have you try this one, remembering to do keep, change, flip. Okay, so again, we are going to keep, change, flip. That means I'm going to keep the first fraction the same. I'm going to change to a multiply. I'm going to flip the second fraction. And now I'm just going to follow my rules for multiplication. I see that I have a n minus 2 on the bottom and an n minus 2 on the top. I see I have a 9n and a 9n I can cancel. And I'm going to go ahead now and write what's left. I have a 7n squared left on the top. I have an n plus 5 left on the bottom. Let's have you try the next one. Don't forget, keep, change, flip. Okay, 2 more examples. I see it's a division problem. I'm going to remember to do keep, change, flip. I'm going to go ahead now and use my rules for multiplication. So I'm going to factor out a GCF. I can see that the top has a GCF of 7x squared. I'm going to go ahead and divide by 7x squared. It leaves me with x minus 5. And now I can do my canceling. I have a x minus 1 and an x minus 1. And now I'm going to write what's left. I have a 7x squared times x minus 5 left, and on the bottom I have an x plus 4 left. It's okay to leave it that way. Last example of the day. Keep the first fraction the same. Change to a times. Flip the second fraction. Now you're just back to doing what you did last night on the homework. So you're going to factor. Factor this top. Factor this bottom. Take out a GCF. And then once you're completely factored, you're going to look for groups that you can cancel. So I can cancel the a minus 7s. I can cancel those a minus 9s. I can cancel those a minus 4s. And you look for what's left, and the only thing left is 8.